Okay, so in this video today we'll be looking at the differential of the exponential functions. Okay, and this has got a very nice property. Okay, the rule is if you differentiate e to the x, okay, you get e to the x back out. Okay, so differentiating e to the x does not change the function. Okay, this is e to the x is the only function with this property. So when we differentiate exponentials, we will get the same exponential back out. Okay, there may be something extra we need to do using the chain rule, but we will get the exponential back out of this function. Okay, let's look at a few examples to see how this works. So looking at example 1, okay, we've got y equals e to the 2x, okay, and we want to differentiate that. So if we differentiate that, okay, well the rule says we get the same exponential back out, which is what we do here, but we must differentiate the power, okay, the exponent, okay, so if we differentiate 2x, we get a 2, so we need to multiply our answer by 2, okay, and that will give us the final answer of 2e to the 2x. Okay, so there's two steps in this. Okay, you get the same exponential back out, you must differentiate the exponent, and then you multiply by your differential of the exponent there. Okay, so my differential of 2x was 2, so I had to multiply my answer by 2. Okay, so it can be a very quick process to differentiate using exponentials. Okay, and that's what makes this rule quite neat. Let's look at a second example first before we move on to some more complicated ones. So here's another example, it's quite similar. So we've got y equals e to the x squared plus 4 over e to the 2x. Now we can differentiate, that's fine. We could use the quotient rule to differentiate this, however it might be easier just to rearrange this so we don't have to do such a long process. So if I rearrange this, I get e to the x squared still, but then I get plus 4e to the negative 2x. Okay, so I've just converted this to look like a negative power. So again, remembering when I'm ready to differentiate now, I need to differentiate, the exponential stays the same, but I must multiply it by the differential of the exponents, okay, which are the powers. So if I keep the first one the same, e to the x squared, I need to multiply that by the differential of x squared. Well, if I differentiate x squared, I get 2x, so this needs to get multiplied by 2x here. And if I deal with the second one, well, I get the same exponent, 4e to the negative 2x, but I must multiply by the differential of negative 2x. The differential of that's negative 2, so I need to multiply this by negative 2. Okay, and if I just combine my answers and make sure I write with positive powers, okay, well that 2x can go to the front of that, so it's 2x e to the x squared. That multiplied by that will give me negative 8, so I've got negative 8 over, and I wrote that as a positive power, e to the 2x. Okay, just a wee bit of notation here. It's sometimes more beneficial to use a dot to notice that you're multiplying these two things as opposed to another x. Okay, we'd have lots of x's about the place, that's why sometimes a dot is probably the preferential notation here, and you will see that a lot in this course. Okay, and it will become more natural to you. So there's two examples where we just had to differentiate the exponents. Okay, you can see it can be quite a quick process, very similar to what you've done before. Okay, it's a lot similar to using sine and cosine when you differentiate. Remember the chain rule part of that, but we can get an answer nice and quick for something we didn't know how to differentiate before. Okay, we'll look at two more examples to see a slightly more longer process, a couple of questions. So we're going to look at product rule questions. So the first one I'm looking at is y equals x cubed e to the 4x. Okay, remember the product rule. Okay, we're going to split that up to get what we need for our rule. So I'm going to let u equal x cubed and v equals e to 4x. If I differentiate u, okay, I'm going to get du by dx equals 3x squared. Okay, I've got that on the right hand side there. And if I differentiate e to 4x, well, we've seen how this works now. Okay, this would stay the same, but I need to multiply it by a differential of this. If I differentiate 4x, I get 4, so I'm going to get 4 times e to the 4x, which is 4 e to the 4x. Okay, so when you get more comfortable with this, you will be able to do this in a much quicker step than what we've done in the first two examples. Okay, so we get 4e to the 4x there. So this was my product rule. Okay, so I need to now substitute in my functions into here. Okay, so u times dv by dx, that's going to be x cubed times 4e to the 4x, so that's going to give me 4x cubed e to the 4x. Okay, which is what I get in my first term. And then if I add v times du by dx, well, v was e to the 4x, du by dx was 3x squared, so I'm going to get 3x squared e to the 4x, which I've got there. Okay, now that is my final answer. However, we like to always simplify our answer if we can, so we can take a common factor out of this. I can take x squared and an e to the 4x out of this. And if I do that, okay, I'm going to get x squared e to the 4x taken out with a bracket. I'd have 4x left in this plus 3 left in that there. So I've got my final answer written down here as x squared e to the 4x bracket 4x plus 3. Okay, so that would be that function there differentiated to give me that answer there. Okay, let's look at a fourth example, okay, just to show you, and that'll be the end of this video. And we're going to look at a quotient rule question, okay, so this is my quotient here. I've got y equals x cubed over e to the 2x, okay, and something to maybe note, you could have actually brought this up to a negative power and used a product rule for this, okay, however, keeping it as positives means I can use the quotient rule, okay, so u would equal x cubed, that'll be the term on the top, my function on the top, v is e to the 2x. If I differentiate both of them, okay, well, du by dx, so u is x cubed, so that's going to be 3x squared. If I differentiate e to the 2x, that will give me another e to the 2x, which I've got here, but I'm going to multiply by the differential of 2x. The differential is 2, okay, so if I differentiate 2x, I get 2, so that will go at the front. I've got 2 e to the 2x there. Okay, so that's me got my functions, and I need to substitute it into my quotient rule, okay, remembering it's got a v squared on the bottom, okay. So if I do that properly, okay, well, if I look at the numerator, okay, v times du by dx, well, that's going to be e to the 2x times 3x squared, so it's going to be 3x squared e to the 2x, minus, okay, minus u times dv by dx, well, u was x cubed, dv by dx was 2e to 2x, okay, I'll put the 2 at the front, so I'm going to get 2x cubed e to 2x there. Now v squared, okay, that means I've got to have to square e to the 2x, okay, so if I square it, it means I'm multiplying the exponent by 2, okay, so that means 2x times 2, which is 4x, I'm going to get e to the 4x as my numerator, okay. So that is my answer, however, there's a lot we can do to simplify this. Starting with the numerator, I can take a common factor out, so let's do that first. Okay, so you can see I can take an x squared e to the 2x out of both terms. I'd be left with a 3 in the first term and a minus 2x in the second term. Okay, now that maybe looks like the final answer now, but we can still simplify, okay. I can actually cancel out my e to the 2x on this line with the e to the 2x that would have been there, okay. Remember, that was e to the 2x squared, this one, which means there was two lots of e to the 2x there, okay, it was e to the 2x times an e to the 2x there, so I can cancel one with one of them, which means I would get as my final answer x squared bracket 3 minus 2x as my numerator, and as a denominator e to the 2x. Okay, so there's a few examples of how to differentiate functions that have an exponential in them. Okay, thank you.